how many terms of the geometric progression 1 plus 4 plus 16 plus 64 and so on must be added to get the sum equal to 5461, right? So let's note our parameters of the geometric progression. As you can see, the first term here is 1, so clearly the value of A is equal to 1, the first term. Next, we look at the common ratio denoted by R, which is, as you can see, 4 upon 1 is 4, 16 upon 4 is also 4, so the ratio between any given term and its preceding term. So our common ratio is equal to 4. And we've been told that all the numbers added together add up to 5461. So that means the sum of n terms of the entire geometric progression is 5461. They've asked us to find how many terms, so in effect they've asked us to find the value of n in this question. Alright, so let's start by noting the formula for the value of, let's start by noting the formula for sum of n terms of a geometric progression, right? So sum of n terms of a geometric progression. Here, if you notice, the value of r is greater than 1, so we will use the formula which is a into Sn, sum of n terms, is equal to a into r raised to n, r to the power n minus 1 divided by r minus 1, r minus 1, right? So this is the formula for sum of n terms of a geometric progression when r is greater than 1. So let's start plugging in the values that we know. So we know Sn is equal to 5461, which is equal to A, which we know is 1, the first term, right? In the bracket we have r raised to n, so we have r, which is 4, right? So 4 raised to n. Now that n is the unknown over here, so let's leave it as it is. Minus 1, entire thing divided by r minus 1, so 4 minus 1. Okay, so let's start simplifying and solving the terms now. So 5461 is equal to, it's just a 1 here, so no need of writing that again. We have 4 raised to n minus 1 in the numerator divided by 4 minus 1, which is 3. So let's shift the terms around. 3 in the denominator here, taken to the other side, goes to the numerator, like division becomes multiplication. Right, so 5461 into 3 will give me 3, 18, I carry 1, 13, I carry 1, 15, 16. So 16,383, which is equal to 4 raised to n, 4 raised to n minus 1. Okay, moving on further, take the minus 1 to the other side, becomes plus 1. So I get 4 raised to n equal to 16,384. Alright. Now, if you want to find the value of n here in the index, you have to make sure that the other side, the right hand side as well, is 4 to the power of something. You have to make sure that the base 16,384 is expressed as a power of 4. So to do that, let us prime factor, not prime factorize, but rather factorize 16,384 with respect to 4. So by 4 once, I get 4, 0, 9, 6, 4 again, 1, 0, 2, 8, 1, 0, 2, 4, right? 4 again, 256, 4 again, 64, 4 again, that's 16, 4 again, it's 4, 4, and then finally 1. So as you can see, 16,384 is 1, 2, 3, 4, 5, 6, 7, 4 raised to 7. So therefore I can say 4 to the power n is equal to 4 raised to 7. And now since the base on both the sides of the equation is the same, I can conclude that the value of n is equal to 7. And that is what we wanted to find in this question. How many terms of the geometric progression had to be added to get the sum equal to 5461? I can say we need to add 7 terms. Therefore, 7 terms of the GP of the geometric progression need to be added. right? And this is our final answer.